Hey everyone, am I audible? Am I audible to all of you? Okay. Madhya, I guess you were absent in my last session, so you missed a major chunk of this this triangle chapter. In last session, we practiced the questions related to this BPT and its converse, and also we wrapped up one theorem also related one similarity criteria you can say, and that similarity criteria was triple A similarity criteria. So we did that. So as you missed my last session, I request you to please go through the recordings of my last session after the session. Okay. So I'm going to start because we did one similarity criteria. So first I'm going to take the problem based on that before I move to the second similarity criteria. Okay. See this problem. This is a very important problem that we have in NCRT. Can you read this problem? Is it visible to all of you? Yes. So Madhya, do you know similarity criteria, triple A similarity criteria, SAS, SSS? Do you know these criteria? Okay, then it's very good. Then it's good, right? So this is the problem that we are going to do, because this is based on the criteria that we did in my last session. So first we are going to do this, and then we will move to the rest of the similarity criteria that we have. So what does this problem says? That's good, Madhya. That's very good if you did, right? So what it says, that a girl of height 90 centimeter, right, is walking away from the base of a lamppost, right? So let us assume that this is the lamppost, right? This is the lamppost that we have. This is the lamppost we have. What's the height of lamppost? Height of lamppost is not given. Oh, height of lamppost is already given to us. If the lamp is 3.6 meter above the ground, this is the height of lamppost. So this is 3.6 meter. Okay. If the lamppost is 3.6 meter above the ground and a girl is walking away from it, let us assume this is the position of the girl. Okay. This is the position of the girl. What's the height of the girl? The height of the girl is 90 centimeter. 90 centimeter means this is 0.9 meter. Okay, 90 centimeter means this is 0.9 meter, the height of the girl that we have, right? Now what do we need to calculate? We need to find out the shadow, the length of the shadow. We need to find out the length of her shadow after 4 seconds. So see how we can do that. This is the distance between the girl and the lamppost we have right now, right? And this is her shadow, right? And let us join the tip of both the lamppost and the girl. This is the figure that we are going to get. Okay, let's say this is A, this is B, C, let's say this is D, and this is E.
Good evening, sir.
Good evening, Shanawaz. So see, what is...
Sorry, I was just late.
Sorry, no problem. I just started with this session. This is the very first problem, and this problem is based on the triple A similarity criteria that we did last time. Okay, this is explanation of that. So now pay attention. This is the distance. This is the distance covered by the girl in how many seconds? 4 seconds. Distance covered in 4 seconds. Okay, this BD is the distance covered in 4 seconds, right? And we have to find out DE. This is the image, sorry, this is the length of her shadow after 4 seconds. Length of her shadow after 4 seconds. After 4 seconds. This DE is the length of her shadow after 4 seconds, right? So we actually need to find out DE here. Since this angle will be 90 degree because the lamppost stands vertically on the ground. Also the girl will stand vertically on the ground. So this angle is also 90 degree. So first, what do we need to find out? We need to find out the distance that is covered by the girl in 4 seconds. That is BD. So the speed of girl is already provided to us. Speed is 1.2 meter per second, and this is the distance that she traveled in 4 seconds. So by using the formula of speed is equal to distance upon time, I can certainly calculate the length of BD, right? So what do we have? BD is the distance covered in 4 seconds. It's a distance covered in 4 seconds, right? Speed of girl is already given to us, 1.2 meter per second. Speed of girl is 1.2 meter per second, right? So what is the distance? That therefore distance BD, which is the distance covered in 4 seconds, will be equal to 1.2 into 4. That is equal to 4.8 meter. So what does this mean? This means the girl covered 4.8 meter distance in 4 seconds, or you can say the length of this BD that you have, it is equal to 4.8 meter. Is this point clear to all of you? Because the speed is 1.2 meter per second given in the question, and in 4 seconds she moved from this point B to this point D. So the distance that is covered by the girl in 4 seconds is BD, and you can you can calculate this distance BD by using the formula of, yes, I'm doing that only. You can calculate this distance covered by the girl in 4 seconds by using the formula speed is equal to distance upon time, right? Madhya, is it clear to you? Because the speed of lamppost is 3.6 meter, the height of girl is 0.9 meter already given, and this is the distance she traveled in 4 seconds, right? Speed, her speed is also given. So if you know the speed, if you know the time taken by her to move from point B to point D, then you can calculate this distance using the formula speed is equal to distance upon time, right? Now since this is the lamppost, right, this is the lamppost that you have, and this is the girl, this is going to be the image. So basically we have to find out DE here in this problem, right? So let DE is equal to X meter. And what does this DE represents? This DE represent length of image after 4 seconds. Length of image after 4 seconds, right? So we need to find out this. So now pay attention, we are going to use AA similarity criteria here. How we can use it? I'm going to consider two triangles, triangle ABE, the bigger triangle, and triangle CDE, and I'm going to see what is equal in these two triangles. So in triangle ABE and triangle CDE, what's the first thing that is same? The first thing is that this angle is 90 degree in both these figure. This angle is 90 degree, absolutely, right? So angle B is equal to D, which is 90 degree. Angle B is equal to angle D, 90 degree each, right? And what's the second thing we have? One angle is common in both. This angle E that you have, it is common in the bigger triangle as well as the smaller one, right? This angle E that you have, this angle, it is common in bigger triangle, which is ABE, in the smaller triangle CDE. So that means we have two angles of this bigger triangle same as the two angles of the smaller triangle, right? And if that happens, then by AA similarity criteria, these two triangles can be considered as similar, right? So we have angle AEB is equal to CED. Angle AEB is equal to angle CED common, right? And since two angles are equal, so we can say triangle ABE is similar to triangle CDE by AA similarity rule. Okay, AA rule, right? And if two triangles are similar, then the ratio of their corresponding side is also always same. Now see how we write the ratio. Corresponding to AB, you have CD, so you will write AB upon CD, right? Corresponding to this BE, you have DE, so you will write BE upon DE is equal to BE upon DE. And corresponding to this AE, we have CE, so this will be written equal to AE by CE. This correspondence is very, very important. Now let's see what are the length of them. The length of AB is 3.6 meter, and the length of CD is 0.9 meter. I am going to write it. AB is 3.6, CD is 0.9. Okay. Now let's go back to the figure. We assume this value DE to be X meter, right? So what is the length of BE? The length of BE is 4.8 plus X, because we need to add both these dimensions. So BE is equal to 4.8 plus X. On the other hand, DE is equal to X. So BE 4.8 plus X, DE is X. So this is 4.8 plus X by X. You need not to put any value in this third part, right? Because that is not important for us here. So you can solve it. This 0.9 will cancel 4.6 four times. So you will have 4 is equal to 4.8 plus X divided by X. Or what will you get? You will get 4X is equal to 4.8 plus X. Or you can say you will be getting 3X is equal to 4.8. That means the value of X I am getting is 1.6 meter. So you can say that the length of a shadow after 4 second is 1.6 meter. Okay. This is in your NCRT, a very, very important problem. You can note it now. Double A part, yes. Shanavas, pay attention. We are talking about these two triangles. I'm going to highlight two triangles. First is this one, the bigger one. A, C, E. Yes, double A or triple A, that's the same thing, right? And this, right? And the smaller triangle is this one, CDE. If you see these two triangles, then this angle is 90 degrees in both, because lamppost and the girl will stand vertically on the ground, and this angle is common in both the triangles. Since two corresponding angles of these two triangles are same, so we can say that these two triangles are similar by double A rule. We discussed double A rule also. Do you remember that double A rule or triple A rule both are same thing? So if you are able to show two angles are same as the other as two angles of the other triangle, then you can write double A or triple A accordingly, right? Yes, that's what we did here. Yes, then we just substituted the value and did it. That's it. You can note it. Noted. Let Shanavaz and Madhya also inform, then we can. Madhya and Kavinash, please confirm if it is done, so that we can discuss second similarity criteria and the problems based on that. Done? Okay. I think Madhya has also noted. So I can move. All right. So let's move to the second similarity criteria. Okay. Similarity criteria 2. Second. we have already covered triple we have already covered triple A similarity criteria. So now we are going to discuss triple S similarity criteria. Okay, triple S also referred to as side similarity criteria. So SSS means side side similarity criteria. Similarity criteria. Okay, so first let me write the statement, then we will prove it. The statement says if in two triangles the sides of one angle, if in two triangles, if in two triangles the sides of one triangle, the sides of one triangle are proportional, are proportional to the sides of another triangle, are proportional to the sides of another triangle. Okay, if they are proportional to the sides of another triangle, then their corresponding angles are equal and hence the triangles are similar. Then their corresponding angles are equal, angles are equal, and triangles are similar. Okay, so please note this statement so that I can move to the next page to make you understand this. Okay, it's not converse, like you want to say converse. Look, if I have to tell you, then I don't think we can say it's a converse of AAA, right? Because in AAA the criteria is different. Here the criteria is different. Although the results are quite similar, in AAA criteria, we used to assume that the corresponding angles are equal, and we used to show that the corresponding side must be same. And in this, we are assuming the ratio of corresponding side is same, and we are to prove that the corresponding angles are equal. So they are in a way related to each other, but yes, you cannot say that they are converse of each other. That is not the correct statement, I would say. Okay. So what is given to here? We are provided two triangles. Suppose this is first triangle, A, B, C. This is another triangle, D, E, F. Right? Look, what is given here? We are given AB upon DE is equal to BC upon EF is equal to CA upon FD. This is given to us. Let us call this 1. And what do we need to show? We need to show this. Angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. That is what we need to show, because if we are able to show it, then according to the previous or the last similarity criteria, we can say that these two triangles are similar, right? So let's move to the proof. How we can do it? How we can do it? Who is going to tell me how this can be done? Any hint how we can do it? Yes, we have to do construction. Look, the proof, the construction that we did in the last theorem, we need to do the same construction here. Let me show you construction using different color. We need to cut off. Yes, we will use that. We will use that somewhere, hopefully, right? So to cut, we have to cut off P and Q such that this dP that you have, it is equal to AB, and this AC that you have, it is equal to DQ. Okay. So what construction do we need to do here? Let me write that. The construction is this: cut off dP is equal to AB, dP is equal to AB, and dQ is equal to AC, right? dP is equal to AB and dQ is equal to AB. Let us call this second. Look, if dP is equal to AB and dQ is equal to AC, then can we replace this AB and AC by dP and dQ or not? Tell me first. Can we do this or not? Yes. So from 1 and 2, from 1 and 2, what do I have? I have dP upon dE is equal to dQ upon F, dQ upon dF, right? That means we have dP upon this entire side dE is equal to dQ upon this entire side dF. So by the converse of BPT, this PQ should be parallel to EF, isn't it? Because this is satisfying the condition for the converse of BPT to be applicable, right? Therefore, what do we have? We have this line, PQ parallel to EF by converse of BPT. PQ parallel to EF by converse of BPT, right? So let us call this angle as, okay, if dPQ is parallel to EF, can we say that this angle is equal to this angle and this angle is equal to this angle, corresponding angles? Can we say this or not? These angles are equal. Yes, because they are going to be corresponding angles, right? So I'm going to write it, angle P is equal to E, angle Q is equal to F. So it implies angle P is equal to angle E, angle Q is equal to angle F, corresponding angles, corresponding angles, right? Now our goal is, what is our goal? See, our goal is to actually show that this triangle ABC is congruent to this triangle DPQ. How we can show it? How we can show it that these two triangles are congruent in nature? Think how we can do that. Yes, look, how we can do this. Can we show that triangle DPQ is similar to triangle DEF? Can we show this or not? Triangle DPQ, this triangle is similar to this bigger triangle by double A rule or triple A rule, you can say. Can we show this? Right? We can show this. So let's prove it. So in triangle DPQ and triangle DEF, angle D is going to be common. Angle D is equal to angle D, that is common. The second thing is angle P is equal to angle E and angle Q is equal to F, that we proved earlier, right? So we have angle P is equal to angle E, right, from 3. So these two triangles, therefore this DPQ is similar to triangle DEF by double A rule. And if these two triangles are similar, we can say that the ratio of their corresponding side will be same. DP upon DE will be equal to PQ upon EF, and this will further be equal to what? This will be equal to dq upon df, isn't it? This is what we got. These things are going to be like these things are going to be equal. Clear? Is that clear, guys? Because we have to now relate two or more than two results and see how we can relate it. Look, AB upon DE is same as DP upon DE, isn't it? Because AB is equal to DP. Can we say it or not? AB upon DE is same as DP upon DE, right? Because DP is equal to AB. And this DP upon DE is equal to PQ upon EF, right? Let me call this 5. So from 1, 4, and 5, what do we have? From 1, 4, and 5, we can say AB upon DE is equal to DP upon DE. And this DP upon DE is equal to what? This DP upon DE is equal to PQ upon EF. Can we say this or not? AB upon DE, AB upon DE is equal to DP upon DE, and this DP upon DE is equal to PQ upon EF. Right? Is this true? Is this true or not? Now this AB upon DE is equal to BC upon EF also. So I'm going to write this as well because this will give our proof. This is equal to BC upon EF also. Now pay attention. If you compare the last two terms, only these two terms, then can you say that PQ is equal to BC? That means PQ upon EF is equal to BC upon EF, right? EF and EF will cancel out. So what do we have? We have PQ is equal to BC. Can we say this or not? This is the important result. Now it's very easy to prove it. Now the theorem is very easy. Yes. So look, now in these two triangles, this triangle and this smaller triangle I'm talking about, AB is equal to DP by construction, AC is equal to DQ by construction, BC is equal to PQ we proved here. BC is equal to PQ we proved here. Can we say that these two triangles are congruent by triple S rule? Can we say this or not? These two triangles are congruent by triple S rule. ABC is congruent to DPQ by triple S, right? So yes, I'm going to write it. Yes. So triangle ABC is congruent to triangle DPQ by triple S rule. Yes. And if these two triangles are congruent, their angles are also going to be equal. That means angle A is equal to angle D, angle B is equal to angle P, and angle C is equal to angle Q by CPCT. Okay, by CPCT. Now we are very close to the proof, right? Now pay attention. Look, angle P is equal to E and angle Q is equal to F, right? And here what do we have? Angle Q is equal to C and angle P is equal to B. So if I compare these two things, can we say that angle A is equal to angle D already, right? Angle A is equal to D, that we already have. Since angle B is equal to P and angle P is equal to E, so can we say angle P is equal to E? Right? Angle B is equal to angle P and angle P is equal to angle E. So we can say angle P is equal to angle E. The same is going to happen here. Angle C is equal to angle Q and angle Q is given equal to angle F. So we can say angle C is equal to, angle F, right? So from 3 and 6, from 3 and 6, what do we have? We have angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. That means the corresponding angles of two triangles are same. Therefore, these two triangles are similar by D. Therefore, these two triangles are similar by AAA criteria, and this proves our result. Okay, this proves our result. Although the chances are very, very, very rare that these proofs will come, of the next result, I'm not going to take the proof. I will only discuss the result. Okay, I have taken proof of two results, so you can note it, and then we will move to the problems of this important problems of this chapter. Sure. In the last part, we just equated the result of third, 3 and 6, nothing else. Okay, angle P is equal to E, angle P is equal to B, so angle B is equal to E. That is what we wrote, right? Similarly, angle Q is equal to E and angle Q is equal to C. Therefore, angle C is equal to E. C is equal to F, right? So what we got is the three angles of one triangle are equal to the corresponding three angles of other triangle, and hence the triangles are similar in nature. Right? That's what we did. Okay, okay. We will not do the proof of the third one. We will discuss the result and then we will focus on the problems. They skipped this chapter, and this is one of the most important chapter. They will cover, maybe they will cover later on. Yes, Madeha, sure. Done. Is it done? Yes, I already did, Shanavas. Done. Okay. Let's Shanavas also. Okay, done. So now only one rule is left, and I'm going to discuss the result only. We will not go into the proof of that. That proof you have to do as a homework, right? Uh, that is SAS similarity criteria, the third and the last one. SAS similarity criteria. Okay. So look, when does this SAS similarity criteria works? It works in situation like this. Suppose this is your first triangle, which is ABC, and this is another triangle PQR. This is A, B, C, P, Q, R, right? If this AB upon PQ is equal to AC upon PR, and if their included angle, this is the included angle means the angle between the two sides under consideration. If this angle A is equal to angle P, right, and angle A is equal to angle P, right, then what do we have? Then we have triangle ABC similar to triangle PQR by SAS rule. By SAS rule. Clear? Is this clear? Like in which situation you have to use it? I'm not going into the proof. We'll focus more on questions, right? If the ratio of two sides and their included angle is equal, then we say that the two triangles are similar by SAS similarity criteria. So let's focus on the problems then. Okay. These are the similarity criteria we have in the syllabus. Try question number 2. Try question number 2 and question number 3, both 2 and 3. First try question number 2, this one. No, we haven't done this. This is based on similarity criteria. Have we done this? Okay, question 2 we have done. Question 3 then try question 3. 3. If we have done this, try 3. Okay. Okay. Yes, we have done this. Try the third one. Shanawaz, I don't think we have done third. We haven't done third. No, Shanawaz, we haven't. The problem was similar to this one, the one which we did, and that problem was related to BPT, right? Yes. Is it done, or do you want me to explain this problem? Do you want 1 or 2 minutes more? Okay, take 2 minutes. Take 2 minutes. Take 2 minutes. Done, Madhya? Good. Done. Okay. I think everyone has done it, right? So let's move to the next problem that we have. Okay. Explain the last. What last? I didn't get this. Do you want me to explain this last part? Using similarity criteria. Okay. So we are given a trapezium. This is the trapezium given to us. Right. We have A, B, C, D. AB is parallel to, and they intersect each other at this. So I'm going to give you a hint like how they did it. Since this is parallel to this angle will be vertically opposite angle. These angles will be alternate interior angles. So this triangle is going to be triangle AOB is going to be similar to triangle COD. Look, there is a way we write this similarity. As angle A is equal to angle C, so corresponding to A, you should be writing C. O of this is equal to O of this, so corresponding to O, we have to write O. Since angle B of this triangle is equal to angle D of this triangle, so corresponding to B, you have to write D, right? So these two triangles are congruent or similar by triple A root. And if these two are similar, you can say AO upon CO is equal to OB upon OD, right? So that proves our result. That's it. SAS, how you can take SAS? How do you know the ratio of corresponding side is same? That is not given anywhere in the question. If you are using SAS, then it's wrong. Because if you read this question carefully, it is not given anywhere. Yeah, that's fine, but like where it is written that the diagonals divide each other in the corresponding ratio. You have to prove it. You cannot take like you cannot use this result to prove that the two triangles are similar. Shanavaz, you made a mistake in this. You have to use triple A, and since when you will be able to prove that these two triangles are similar, you can say that the ratio of their corresponding side is also going to be same, right? That's how you have to do it. Is that clear? I think you used this result only, which is not possible, right? So I'm going to move to the next one. All right, Shanavas. Question number 4 first. Question 4. Same base. Which two triangle are okay? Triangle PQS and TQR. Yes, if you see the base of PQS and TQR, then yes, QS is a part of QR only. So yes, the base are same only, but you cannot say that they are equal. Okay, QS is a part of QS is a part of QR, but this QS is not equal to QR. Is that clear, Shanavas? So never write that these are equal. Done. Okay, Shanavas. For others, only last 1 minute is left. Then I will explain it. Done, Madhya. Good. Let Kavinash also respond. Kind of. So those who have done it, I request you all to move to sixth question. Sixth question. Not getting the last part means I didn't get what are you trying to say. You have to do only one change, Kavinash. Angle 1 is equal to angle 2. So the side opposite to these angles will be equal. That means PQ will be equal to PR. If you replace this PR by PQ, you will get your proof. Because in that situation, you can apply in these two triangle SAS similarity criteria. That's the only thing which is needed. Okay, because this QR upon QS will be equal to QT upon PQ, right? And also angle 1 is equal to angle 2, which is the included angle. So both of them will be similar by SAS similarity criteria. Do you get it, Kavinash, what I tried to explain? You need to do only one change in this. You did that. So that is what is needed to be done, nothing else. You need, like, nothing else is needed to be done. You didn't get the answer. If you did that, that is the answer in itself. Look, the ratio of these sides will be same, and angle 1, which is a part of triangle TQR, right, is equal to angle 2, which is a part of angle which is a TQR. Just a minute, TQR. Okay, and done, Kavinash, nothing else. Look, angle 1 is common in both of them, right? Angle 1 is present in this triangle also, TQR, and angle 1 is present in this triangle also, PQS. So this angle is common in both. So that's the third thing that you can use. And both these triangles will be similar by SAS in that situation. So what have you done? Okay, you got it. No, that angle 1 is equal to 2 is given only for one purpose, and the purpose is to actually get this relation between PQ and PR. And this relation helps us to replace this PR by PQ, making these two triangles similar by SAS. Right? That's the only goal of this angle 1 is equal to angle 2. That's it, right? Yes. After that, you can also move to question number 6. Done, Madhya. Very good. Very good. If you have done it, let others also do. Although I'm gonna explain this question in detail. All right, Shanavas, I will explain. Confused? So let me explain, guys. We are given this chapter, like you have to put in a lot of efforts in this chapter. This is the only chapter will require effort, and also we have circle. Rest of the chapters are very easy. So triangle ABE is congruent to triangle ACD. What does that means? That means AB is equal to AC, right? This side AB is equal to AC, isn't it? Also, yes, yes. AB is equal to AD, this side. Let me mark it. Hmm. I don't need BE is equal to CD. That is not required, I guess. The second thing I have is AD is equal to AE, isn't it? AD is equal to AE. Clear? Yes, Madhya, correct. So these two are equal by CPCT, and also angle A is common in both because they are congruent also. So angle DAE you can say is equal to angle BAC, right? And all these results are by CPCT. Is this clear to all of you? Let me call this one result, this second, and this is third. Is it clear? Yes? Okay. Now divide first result by second result. You will get the proof. Divide 1 by 2. So if I divide 1 by 2, I will get, if division of 1 by 2 means you need to divide the left hand side or the left part from the left part, and the division of right part from the right part. So you will have AB by AD is equal to AD by EE. AB by AD is, sorry, AB by, sorry, AB is equal to AC. This should be AC is equal to AB by AD is equal to AC upon AE. Is this clear? That means in these two triangle ADE, in this triangle ADE, and in this bigger triangle ABC, the ratio of their corresponding side is same, because we got AB upon AD is equal to AC upon AE. Also, this angle is equal in both. From 3, what do you have? We have angle DAE is equal to angle BAC, right? So can we say that these two triangles are similar? Triangle ADE is similar to triangle ABC by SAS. Can we say it or not? Can we say it or not? That proves our result. Yes, we got the answer. So it was not difficult. You need to think and you need to practice to learn how to relate the different results. That's it. So the next problem that we have to do is 8th. The problems that I am not taking, yes, Kavinash, you will learn that when you will practice more and more questions, you will learn that, right? Even like when I did this chapter for the first time, I was also not able to do it. The more you will practice, the more you will get hold on these concepts, right? So don't worry. The questions that I'm not taking here, that questions will act as a homework automatically. Okay, I'm taking the important ones here. Try it, 8th one. No, Kavinash, you have to draw diagram yourself. Nothing is given in this problem. You have to try to draw diagram yourself. First, try it yourself. If you are not able to do, I'm here to help you out. Don't worry. Reread the question. Okay, you will certainly get. Like, read the question step and try to draw the diagram step by step. Don't worry, I will explain if you're not getting. First, try to put the efforts. Is it done? Do you want me to explain? Are you getting like what will be the diagram of this question? Okay. So okay, let me give you a hint when it comes to diagram. E is a point on side AD. Look, uh, this is the parallelogram that I have. Let's say A, B, C, D. E is a point on side AD produced. So if I produce AD, then this is the point E, right? Of a parallelogram, this BE intersect. Let us join BE. This BE intersects CD at F. This is F. So this is the figure that is given to us, Kavinash. But they are done very good. Madhya, if that is done, you can just a minute. Okay, I'll show you the another problem. Just let them also attempt it. Is it done? Okay, Kavinash, you also confirm if it is done. Okay, let Kavina. If this is done, both of you can try. Both of you can try this seventh problem. Seventh, Shanawaz and Madeha. Done. Okay, Kavinash, you can also focus on seventh one. With AA, just give me a second. AEP CDP. Yes, yes, correct. Correct, Shanawaz. Yes, because one is 90 and other will be vertically opposite angle. So yes, AA can be used. But write the correspondence properly. Mm, EPDB. Just a second. Let me see what you are saying. EP. Are you talking about second part or third part? ABD. Which part are you talking about? Second. Okay. ABD. ABD is this. Okay. CBE. CBE. So in ABD and CBE, this angle is 90-degree and this angle is common. So both of them are also equal by double A rule. Clear? Both of them are also similar by double A rule. Yes, one is 90, one is common. So, Kavinash and Madhya, have you done the first two parts? Have you done the first two parts? Okay, good. Very good. So, but if we add EPDB in triangle APE and triangle CPD, triangle APE and triangle CPD. Look, Shanawaz, what we are talking about. We are talking about similarity here. The point that you raised, that works well when we are talking about congruency or the area part, right? Since we are talking about similarity here, we cannot use these results which are mentioned by you. Are you getting this? If you are adding a particular area to both of them, then we say that the area of the first figure will be same as area of the other one. So avoid that. That works in case of congruency, or you can say area. Okay. Yes. So first part is done, second part is done. What about third part, guys? Is third part over? Third is AEP. Which congruency, Madhya and Kavinash, in third one? Which similarity criteria? AEP and ADB. ADB. Yeah, same. Yes, yes, right. So I think this is also very easy. Yes, Madhya, Shanawaz, Kavinash, that's easy. PDC, PDC is BEC, BEC. So this can be proved using first three results. You can see PDC is similar to AEP. AEP is similar to ADB. ADB is similar to CEB. So this will be similar to this. So this last result we can derive using the first three results. So is this problem clear to all of you? When you will, like, what will happen is, when you will be able to tackle the questions related to this chapter, that interest will start developing automatically. But C is common, right? I didn't get this point. C is common. Yes, one result is common, which is relating the other two results. Are you getting this? One result is common, which is relating the other two results. That's how we got. Yes. Okay. So, like, is the similarity criteria thing clear to all of you? Because we have more problems, no doubt. But the problems that we did till now, are these clear? Okay, very good. Very good. In this, on this page number 141, let me tell you the important problems that we have, which we're gonna practice in the next session, hopefully. Because this 11th we will practice. This 16th for sure. 15th is similar to the word problem that we did today. Shanawaz, do you have NCRT? I will share the file. I already shared the files for the last two sessions, right? So this is from NCRT only. If you have NCRT, just for your reference, I'm telling you, because in NCRT we have very good questions, especially of this chapter. So your first goal should be to have a very good command over this topic from NCRT. Then you can move to any other thing, any other resource. That's what my personal suggestion would be. So we will do 11th. I'm talking about the important ones. 14th. 15th is similar to the word problem that we did in the very beginning, so you can try it yourself. And 12 and 13, we will do these 1 2 3 4 5 problems for sure here. Okay, is that clear? And I have already shared the notes of my last sessions also. Okay, and if you have any issue or any problem in the, if you have any issue or any problem in the theorems or the result that we have discussed, let me know. I will rediscuss that in the next session. So in next session we will wrap up this similarity criteria, and hopefully we will start with the next topic, which is Pythagoras theorem. And also we have this the relationship between the similar triangle and the square of their corresponding side, the ratio of the square of their corresponding side. So we all are going to discuss that in the next session. Is that clear to all of you? Clear? Clear. Okay guys, thank you so much for attending session. See you all in the next session scheduled next week. Till then, bye bye, take care, be safe everyone, bye.